Hey everybody. I I think I will chair today. I think we've had a bit of some technical issues on uh, the co-chairs connectivity to the meeting today. So to get things going, I think we have waited the appropriate 5 minutes after the start of the hour. First question for anybody is anybody have any announcements or something or introductions they want to make before we get going with today's meeting content?
Someone I think is joined from an outdoor location, and there is a lot of background noise that includes birdsong and related things.
Yes, I'm hearing that too. It looks like it's Daniel McGalt.
Yeah, I mean, I'm gonna try to shut down the mic.
Thank you.
Um,
Not quite an announcement, but any announcements or introductions?
I have a bit of an announcement. So, in June, the TWI SIG is working on a submission to Vienna IETF, and we're bringing together ideas from the TWI SIG, the Identity Bridge Blueprint that's being developed by the TAC, and some other things, and we will effectively be presenting to the Vienna IETF an extension to the RATS architecture or proposal, informational draft, that shows how we can use remote attestation to light up the use of basically attested environments against all existing relying parties. So be that with short-lived bearer tokens or X49 certificates or workload identity tokens, we're basically bringing together all of these technologies. So if you want to participate, join our meetings weekly on Tuesdays.
Great, thank you, Mark. Thank you very
Mhm.
much. Any other announcements? Okay, good. Let's get going with the today's content. So today we have Paul Howard, who is going to discuss supporting RATS endorsement distribution in Verizon, if I can pronounce that correctly. And I suspect this is going to be a discussion, or at least including, yes, CoServe. So Paul, take it away.
Yeah, sure. Yeah, let me just get into. Okay, is that presenting as a slideshow?
Yes, it is.
Okay, cool. In that case, I will get started. So, just a minute. You have to pardon the coughing. I'm recovering from a cold. Um, okay, so yeah, hi everyone. Thanks for the agenda slot. So I'm Paul, software architect with ARM. I focus mainly on prototypes and proofs of concepts, with a bit of standardization work almost so mixed in. So today's topic about endorsement distribution with Verizon and CoServe. This is not entirely new in this forum, right? I have presented on this topic before. So today is something of a refresher and an update, and hopefully time for some interactive discussion as well. And perhaps this will be new to some of you on the call, so or listening in on the recording. Okay, so this is a CCC meeting, so I thought I'd try to motivate things from the angle of a CCC project. So this is Verizon. This is a simplified schematic of how it operates. I've left some details out to keep things simple. So Verizon provides the components that are needed to build a scalable and interoperable verification service. So it has an endorsement provisioning API where supply chain actors can push endorsements and reference values into the system. These get ingested into a store, and there's a verification API which allows a caller to submit evidence. The verification engine within the service can then check the evidence against the provisioning endorsements and reference values that were ingested into the store. And there's policy in there too, although that's not shown. But all of this gets crunched down into an attestation result that is then communicated back to the caller. which could be an attester or a relying party, depending on the interaction model. But that's Verizon's service model in a nutshell. So far, so familiar. So with that model in mind, what if we wanted to move the verification logic somewhere else, right? So we wanted to externalize it to not rely on an online service call for every verification. We might have some verifier logic that is linked elsewhere with relying party code, for example. Sometimes this is a better fit for the application architecture, or it provides performance characteristics, or whatever the justification. Let's just suppose that we have this separate verifier component implementing the RATS verifier role. So it will consume the evidence, it will apply the policy, and it will produce the attestation results. Being a verifier, though, it still needs access to those same endorsements and reference values that we used in the online service model. Those need to come from the supply chain. In this picture, the rest of the architecture can actually just be the same, right? It still might be useful to have a service that has a trust relationship with upstream endorsers and reference value providers. It might still be useful to provision those endorsements into a store. Verizon is perfectly placed to be able to do all of that. Still, even if we were not going to use it for its internal verification engine. The only thing that's missing then is a way for that separate verifier to pull them out, represented by the question mark, right? So we don't need an endorsement provisioning API here. What we need is an endorsement distribution API. So it's something that allows the verifier to become a client of the service and to make queries into the service to get the artifacts that it needs, cache them locally so that it can then verify evidence without having that dependency on the service every time. Now, the advantage of an architecture like this is that you have a service that could do both jobs, right? It could either be a verification service or it could be an endorsement distribution service that provides artifacts to these externalized verifiers, right? That's one of the nice things about Verizon's architecture being the way it is. It really would only be a matter of which APIs you choose to activate and make available to clients. But you might also look at a diagram like this and think, well, why not cut out the middleman, right? If I've built my own verifier, then why don't I just get my endorsements and reference values directly from those originators instead? Which is a perfectly valid question and a perfectly reasonable deployment choice, but it doesn't eliminate the problem entirely, right? It only moves where the question mark goes, which hopefully we can see more clearly if we try to generalize the picture, right? So this is.
Excuse me, Paul.
Oh, yeah, sure.
I'm piping up because you switched the page. So I had a question on the last page. Actually, I had two
Oh, yeah, okay,
questions, and
sure.
I guess yeah. Mechanically, how do you want to handle questions? Do you want to like answer it all at the end, or do you want people to kind of?
I guess I don't mind too much. We can try to interleave, although if we're in danger of not getting through the material, I might have to punt some things to the end. But yeah, go ahead.
Okay, okay. And do you want me to watch for raised hands and inform you so you don't have to watch?
Yes, please, if you wouldn't mind, because
Okay,
I'm only using a single laptop screen here, so I don't have good
perfect,
visibility of the whole Zoom view.
perfect. I'll do that. So my question on this slide is the the box at the bottom that says separate verifier. That in my head, has some trust anchors that it uses that it enforces and that it has to honor in terms of what it trusts to do the verification. And when the
Hmm.
diagram is all kind of glommed together, it's essentially those parties on the left, the endorsers and the reference value providers. And once we break it apart, then the middle box also becomes a separate trust anchor in my mind. It's a separate entity that has to be trusted. That to me is a very notable event. And so do you is that something that's official, that's highlighted elsewhere in like some documentation in CoServe, or is that not thought of to be kind of like a significant event? And I know we've talked about this in the past, but the
Yeah, Yeah, we certainly have, and I will give the same answer, right, which is that CoServe itself, and we haven't actually really got to CoServe yet, but CoServe
Mm,
itself as a conveyance protocol is kind of agnostic on this. So what we've tried to do in CoServe is we've made it as descriptive as possible so that all trust anchors can be conveyed,
mm,
and choices about who trusts whom and to what extent are not
yeah,
are not
yeah.
opinionated in CoServe, and the only reason this diagram looks the way it does is because I wanted today to be a little bit more about Verizon and the stuff we've done to kind of
Mm,
demonstrate CoServe can be implemented.
mm,
Therefore, I've drawn pictures that might lead you to certain conclusions, but they're not necessarily
mm, mm,
prescribed or opinionated
yeah,
in the pure sort of interface model.
yeah. I just so from my perspective, running a verification service or thinking about delivering some verification logic, anything that's kind of outside of my control has to be measured and trusted. And so when this splits something that was conceptually one thing that I ran, like an instance of the Verizon service, and says, okay, I'm going to split some part of it out and it's going to become external, then that just does move another work item to me in the terms that that thing has to be measured and trusted. And just raising it for awareness. And if anybody like says, wait a minute, that's not the case, and here's why, I'd love to hear it. But otherwise, please feel free to just continue.
Yeah, sure. And yeah, hopefully in some of the coming slides that we'll be able to add some color to that as well. Let me carry on for now because actually this slide is sort of part of the answer to that as well, right? So um, this is trying to generalize the picture. So Verizon is not represented here now, right? There's still just an illustrative example, so don't read too much into it. Like I was just saying in answer to that question, right? We always try to be neutral and non-prescriptive about how many separate entities there could be. But imagine situations like this or parallel to this one, right? So I might want to retrieve hardware endorsements from a hardware provider, but then firmware or software reference values might come from somewhere else. And there could be some platform integration piece that wants to assemble and aggregate reference values from different sources and then present them as an integrated whole, right? And I might want to pull stuff directly from those sources. So many permutations are possible, and this is kind of exactly the point, right? This is why a common protocol for endorsement and reference value conveyance offers a benefit, because no matter what arrangement of providers and consumers you have, it's about sort of aligning to a single interface, because otherwise this kind of landscape is ripe for a lot of needless fragmentation. Okay, so CoServe then, yeah, so we've already kind of talked about it a little bit. So CoServe's the concise selector for endorsements and reference values. It's not a standard yet, it's a draft standard proposal in RATS, very closely related to CoRIM. CoServe complements CoRIM, and by that I mean that it fulfills a function that CoRIM alone does not have, namely the ability to make queries, right? So CoRIM is fundamentally an assertive data format. It's great for describing environments and the relations that apply within those environments, but what's needed is a way for the verifier to ask for stuff, right? Catering for those kinds of situations that I described earlier, where there's a verifier of any kind that needs to pull relevant artifacts from supply chain sources or aggregating sources, whether it's a locally linked library in the relying party or whether it's a service, it doesn't matter, right? So CoServe takes some additional steps beyond CoRIM to make this possible. It is a data format. It's compact, it uses CBOR encoding. It could be exchanged in a variety of ways over different transports. So it's flexible, I guess, and agnostic in that way. But it also specifies an HTTP REST API binding, which is kind of the clincher, really, because although it's a data format, it's also an API. It has a dynamic functional description, which CoRIM doesn't have on its own. And there's also one very good feature of the API, which is that it's very cache friendly, making use of standard HTTP caching, and I'll have some more to say on that later. little bit of detail then. So I said that CoServe is a query language. This, I guess, is a high-level anatomy of the CoServe query. Query goes in, results come out. The producer or server you can imagine is, could be a RIM service or an endorsement service, and the consumer or client would typically be an attestation verifier. As I said, the query language is very tight, it's very simple. You can select for trust anchors, endorsed values, reference values. That's sort of basically it, right? It's not an arbitrary query language. Remember that close tie with CoRIM. So the kind of stuff you can select for is the same as the kind of stuff that CoRIMs can model natively. So you can select according to the testing environment, which could be a device instance or a device group or a class. And as of the latest draft, you can also select just by the identifier of the RIM document itself, right? It's something like a COMID identifier. You can also state whether you want some kind of aggregated view or whether you're happy with just the raw materials from disparate sources. And you can provide any stateful aspects of the attesting environment as well, such as version information, which might impact the data that comes back. And this final point about the query is an important design characteristic. So CoServe encodes to CBOR using deterministic encoding rules. What that means is that the same material query will always encode to the same byte string, which makes it a great cache lookup key. You can use that byte string, for example, as a base 64 encoded URL path. It's still a query, but effectively it's now become a stable identifier, which is great because it enables both server-side and client-side caching. RIM data are used a lot, but they don't change much relative to how often they're used. So caching is great because that reduces the load on the network and on the origin server.
Hey, Paul, Gary has a question.
Yeah, go ahead, Gary.
Not a question. I'm just kind of adding something as far as selection by environment is concerned. We are actually actively extending the spec, and hopefully it'll be in the next version to allow selection by domains. And domains, for everybody's information, is how CORM defines a grouping of testing environments and a hierarchy among those testing environments as well. That wasn't in the spec currently because the quorum draft was evolving a little bit with respect to that, but that is stabilized. But the nice thing about the existing query interface is when you can query for an environment or query for a domain and using the existing query interface, because domains also have the same identifiers, CBOR identifier structure as environments. So hopefully that should be in by the next version of the spec. Yeah. All right.
Okay.
Thanks.
Yeah, that's cool. Thank you, Gary. Okay, so I think I got to talking about the results. So what comes back from a CoServe query is always a CoServe result set, which also is CBOR encoded. And it can be signed using COSA. It echoes the client's query back, which can be useful for a sanity or an integrity check. And it conveys artifacts. So you can think of RIMs or manifests as being artifacts. There are two categories of those, which I'll talk about on the next slide. Okay, so a CoServe result set is a uniform wrapping structure. There's quite a lot of flexibility in terms of what it can contain. So I've sketched out two broad categories here, really just separated by whether there's any kind of aggregation going on. I talked a little bit about the idea of aggregating. So this is something that the data model supports, but it's not something that necessarily happens, right? It's not an essential part of CoServe or any implementation of CoServe. You can use CoServe to just obtain RIMs. That's the case on the left, where CoServe result is really just a containing wrapper around one or more RIM files. I've shown them as CoRIM in this case, but there is flexibility there to use other formats. So you can just do that. You can just wrap CoRIMs in CoServe results, but Alternatively, over on the right, you have this model where there is collection or aggregation going on. In this case, the CoServe result set can directly contain some of the co-rim triples pulled out and collected in a way that makes it easier for the verifier to consume. So the verifier can then decide whether to trust that aggregated view as it is, or alternatively, it can request all of the individual sources that contributed to that. If you're willing to, if you're unwilling to place all of your trust in an aggregator, then you can go and inspect all of the individual contributions to the aggregation and go and check that you have a trust anchor for those two. So there's flexibility there in terms of the structure and in terms of the trust model. So quite flexible, quite future-proof, and there's, as Giri mentioned, there is some additional work happening to support other styles of query as well. Okay, so now sometimes in forums I present this stuff, and a common question I get is, why even go as far as defining APIs and protocols for this stuff? We've got co-rims, can't we just download those from static URLs and be done with it? And it's an entirely reasonable question, right? Rim locators do exist. They're part of the co-rim spec. What I tend to say in response is that actually we've worked really hard on making CoServe look as close to that as possible, while keeping the door open for some server-side smarts and dynamic behavior as well. So if you look at the HTTP binding for CoServe, it's super simple, right? It's not a complicated API with post requests or any kind of state. We are just doing a get on a URL path. The query is the leaf item on the path, and we've defined those encoding rules so that query URLs are completely stable and hence cacheable, just like any other web resource. And you can do that just using off-the-shelf caching middleware. So we kind of have the performance advantages of that, while at the same time having the opportunity for the server to apply some intelligence. So for instance, it can set the cache control headers on those HTTP results so that caches are invalidated on some suitable cadence. It can also bundle multiple rims together or aggregate, as we've seen. And it can deal with stateful environments as well, where the endorsements that are returned might be different depending on some aspect of state on the attester side. So really what we're trying to do with CoServe is hit a kind of sweet spot, I guess, trying to provide the best of all worlds. We have that dynamic capability to whatever extent it's needed, but we also have standard HTTP resource caching to reduce the loads on the origin server. And because we're trying to set up CoServe to be a standard, it's only likely to succeed in that regard if it can at least handle some level of dynamism, right? So there are endorsement. This is evidenced today by endorsement services that do exist. That do have dynamic query mechanisms. AMD's KDS, for example, the key distribution server, generates certificates based on TCP version information, right? So there is stateful information that is not just a static URL download. So that's why we're putting forward CoServe just in that place between mostly looking like a URL, but also giving you the opportunity to do some server-side smarts. Okay, so.
Excuse me, Paul.
Yes, go ahead, Greg.
Slide switch, so I'll inject the question. Maybe you'll cover this further on, so please just pause till that, or answer it then. Are there any metadata kind of queries for CoServe? Right. So for example, enumerate, the endorsers or reference values providers that you represent, and perhaps what's the timeliness of the last refresh from these, endorsers, anything like that? Or is it just query, is it specific to querying?
So far, no. Well, that is to say that there is not a. Oh, so sorry. This is a terrible answer. Let me rewind and start again. Right. There is one metadata query that is possible through what we call the well-known interface. So basic configuration information of what the service is able to do, what it is able to support. That is available via a specific mechanism, via a well-known URL as a kind of bootstrapping stage. So that's one answer. Another answer is that some metadata can be bundled into. There is some background noise coming through.
Yeah, excuse me, Michael. I think you have your mic on and we're getting some bleed over. Thank you.
Yeah, thanks. Where was I at? Right. So places where metadata can reside. So if you look at the CoServe query result structure, you will also notice when the aggregation model is being used, the aggregated corim triples can be annotated with the trust authorities that those came from, if you see what I mean, right? If they were obtained from some upstream supply chain source, then a trust anchor for that source can also be included in the result. But to answer your question in the most direct way, there isn't a metadata API that we have stood up alongside the query API. It is just the bootstrapping and the query mechanism today. So that would be an interesting conversation, if there is a use case where you think um, additional facets to the API might be useful. I want to be a little bit careful with feature creep, right? Because in some of the other drafts that has been a problem. We're trying to keep this one fairly small and focused. And also the CoServe query language is somewhat independent of APIs, right? So it would be possible to develop a new API as maybe kind of a separate thing, a separate piece of work, rather than actually make it be part of CoServe. I don't know, I'd be interested to have the conversation for sure.
I can just imagine if I were using this, I would want to understand what set of endorsers it represented, that it had, accumulated, the endorsements for, and how timely those endorsements were, right? Because there's, different endorsers have different expiries, different refresh cycles, different revocation mechanisms. So getting some insight into that might be kind of required for, I can imagine, for some verifier scenarios where you have to like ensure perhaps, like within 24-hour, revocation checks or something like that. So, and maybe those are just advanced
Yeah.
scenarios and say, don't use this kind of
Well,
system for, but um,
yeah,
ideally
so
that wouldn't be the case.
the particular scenario that you've outlined, I mean, I think the intention there today is that whoever is implementing your CoServe provider, whoever is sitting on the server side understands the other providers that it is talking to and has intelligence about that stuff. And rather than convey it as metadata, what it would tend to do is use that intelligence to set the cache control headers, right? If it knows that it's talking to N other, providers of endorsements and it understands their refresh cadence, then it would choose a kind of mathematical minimum of those, I guess, and set the cache control headers accordingly. So because then what it means is that it's just an off-the-shelf HTTP caching problem then, right? Rather than something that's got to be kind of negotiated through APIs and additional parts of the
Yeah.
protocol.
I think if the space is small and you're working with like, one or two partners, then the scenarios don't boil down to, oh, knowing what you have, because we've talked about that and agreed upon it. But then that scenario would boil down to, I need to perhaps or perhaps not, but double check that some expectations are met, that, the endorsements were refreshed within, the last N hours or last N days, in a broader system where there was lots of folks who did this, and perhaps in the pluggability model, you might say, well, from the registry of known aggregators, CoServe aggregators, which are the ones that support the set of endorsers I need, and then filter your list to that. But that's probably a pretty far-fetched reality. So I don't know if
Mm.
there's any strong demand. I just as I think about this, there's some questions that would immediately come to mind if I was thinking about the design to include it. Thank you for commenting on it.
Sure. Yeah, sure. No problem. No, thank you for the question. Um, okay.
Gary has his hand raised again. I
Oh,
want
I
to
beg
say he
your
has a
pardon.
question.
It's and once again, it's not a question. It's kind of going more follow up to your question to back to you, Greg. Um, there's nothing in the CoServe design that stops what I'll call chaining of CoServe queries. So even though the query interface can be kept, in my opinion, as is, the you know the service that's handling the CoServe query could in turn create other CoServe queries in order to satisfy the service. So I gave the example of a domain-based query. A domain can be consisting of multiple attesting environments, and the attesting environments can actually come from different RIM. Can correspond to different RIM sources. There's nothing to prevent the CoServe service used by the verifier to take that domain identifier and query other RIM services accordingly. So I give a kind of crude example. Um, let's just, when Paul actually originally proposed this work in the IETF, he cited he cited the exact problem you're talking about, the fracturing between different RIM services, and he cited AMD's KDS and in I believe NVIDIA's RIM services, two examples of that. Well, let's assume hypothetically AMD's KDS service evolves to support CoServe. A query comes in that actually has a domain which consists of an AMD attester and an NVIDIA attester. Well, the KDS can actually recognize that, and when it gets that request, send a request off to the NVIDIA RIM service, get both RIMs corresponding to both the testers, and return that. So, so the query interface doesn't need to change. The RIM services that are being contacted to satisfy the query, query, though, can take on different topologies, but as long as it's sufficient to satisfy the request. So I think from that perspective, I think it's meant to actually hide some of the complexity that cloud service providers like Azure are seeing, having to go one by one to each RIM provider to actually validate a domain. Okay.
Sure. Thank you, Gary. Okay, so we've talked mostly about the interface. So let's bring this back to Veragon and talk about implementation. So hopefully I've made it clear of the need for a pure common interface that's separate from Verizon, though, because the greatest industry benefit would come from all supply chain actors adopting this COSA interface, regardless of whether any Verizon components or services are being used or not. So that's why that's a wholly separate effort in the ITF. The RATS working group is the ideal place to define that. But Verizon has a rich history of being the proving ground, if you like, or even a sort of reference implementation of a kind for the designs in RATS. So, if you just go and look at the Verizon project, not just the services repo, but the whole set of repos in that GitHub org, there's nearly 50 of them now. There's a whole ton of stuff in there, and it's growing all the time. You've got support for CoRIM and EAT and EAR and CMW, plus a whole bunch of tooling and examples and demonstrators. And so the Verizon project presents itself as the natural home for implementations of CoServe, which are now quite advanced. So, for instance, we have got we've upstream library support now in both Go and Rust. So both of these libraries implement the full CoServe data model. Not quite up to the current published draft, because we've recently published draft 6, which has a few data model changes that we've not caught up with yet, but much of the support is there, along with all of the CBOR serialization and deserialization and the COSE signature support as well. So these give you the basic capability to parse and manipulate CoServe data. There's some additional support in Rust on the client side, so the Rust API client library can execute CoServe queries against a server. It also pulls in the HTTP middleware support from the Crates ecosystem to enable the client-side caching of CoServe. So that's all mainline, that's all available today. I've got some unwanted, let me just build out the, I've got some unwanted animation on my slide deck. I'm very sorry about that. So the Verizon service repo also supports CoServe API endpoints. So it means that you can stand up a Verizon service and deploy it as an endorsement distributor using CoServe as well as a verifier. So it exemplifies CoServe by implementing the API as per the draft. So it has these new get methods. There's a method to get the discovery details from the well-known URL, which I was mentioning earlier. And there's a method to execute a transactional query using the HTTP contracts and behaviors that are normalized in the draft. Like most things in Verizon, the actual implementation is delegated to plugins. So the store plugins will query the native Verizon data stores to produce the results. But also, and I think this is kind of to Giri's point about proxying, right? This is one of the things we did as a hackathon project in one of the recent IETFs, was to have this kind of experimental proof of concept for proxy plugins, which were these show CoServe as a proxy layer. They get their data not from Verizon's internal stores, but from external cloud services. So we demonstrated those for NVIDIA's RIM service and for AMD KDS. And the reason we did that is because we were trying to put the draft through its paces as a potential standard, and to do that, we wanted to look at some existing real-world technologies and to make sure we could cater for those using a single uniform interface, and that code is still there in the services repo. So bringing all of this together, there's also an end-to-end story. So there's a fully encapsulated demo now in the repo as shown. There are some README instructions for that. What it does is it performs evidence verification and appraisal with a simple and self-contained command line tool, with endorsements and reference values pulled using CoServe from a Verizon service endpoint. So it uses ARM CCA and CCA profiled CoRIM and CoServe, but that's just implementation status, right? There's nothing in this work that couldn't be expanded to other schemes with a bit of additional effort. So Verizon is our endorsement and reference value service in the demo. So it provides the CoServe endpoint from which we can pull down those artifacts. There is a pre-configured live Verizon service that Lenaro make available on a purely experimental and as-is basis. So it has the CoServe endpoint switched on. So that's what we use for the server side in this demo. All of the client side is in the Rust tooling and libraries. So that Rust API client library, that's how we send CoServe queries to the server to get the responses back. That client is also enabled with the standard HTTP caching middleware that I mentioned, and it uses the cache control and expiry headers set by the server to cache things locally for limited periods. It means you can actually run this whole demo sort of fully unplugged from the network, if you like, while those caches remain valid at least. The actual verification engine, in case you're wondering, is the CoRIM verifier. That's CoVer, which is another component within the Verizon umbrella project. So CoVer is a Rust implementation of the verification algorithm as per the CoRIM draft. And the reason it's applicable here is due to the high compatibility between CoRIM and CoServe. They are similar to the extent that you can feed CoServe results into a CoRIM verifier with just some relatively lightweight glue. And that's also available. It's all mainlined. All of the moving parts are in their mainline branches of their respective repos, which is nice. And just want to quickly mention one of the more recent innovations with CoServe in Verizon as well. So I've talked a lot about CoServe as a query language for endorsement and reference value distribution. But because of its ability to characterize environments and individually identified RIM documents, it can also be used as in life cycle control as well. So there's some new ongoing work in Verizon at the moment to add lifecycle management APIs alongside the existing endorsement provisioning API, or rather to extend the endorsement provisioning API with these kinds of capabilities. So in a dynamic firmware update scenario, for instance, we might be submitting multiple co-RIMs for firmware components as they progress through different versions. And there will be periods of time where the old versions are active side by side with the new ones. But then later we might want to deactivate the old ones so that they're no longer considered valid. CoServe, as it turns out, is a good way to nominate RIMs for activation and deactivation in this kind of scenario as well. So that's something of a sideways sort of innovative use of the same technology. And I think that's about all I have, but I don't want to end without a vote of thanks and huge appreciation to all of the people that have contributed so much towards this effort. It's very fun and rewarding for me to talk about it, but these people are the reason that there is anything for me to talk about at all. Thomas, of course, for his characteristically superhuman efforts alongside his Linaro colleagues, and Shafali and Danus in the Fujitsu team for their huge contributions towards that end-to-end story that I described. My ARM colleagues, including Sergey and Yogesh, for their enormous technical help and insights. And of course to those in community who have co-authored and contributed to the spec, Carl, including Carl and Giri and Henk and Ding. So thanks to all those fine people, and I will close out with the resources slide. There's a link to the draft for CoServe and the GitHub repo where you can raise issues, and also a link to the demo repo that I talked about. And I think that's all I had. So thank you very much, chairs, and for everyone for listening. We have some time left, thank goodness, if there is further questions or discussions.
So thank you very much, Paul. This was fascinating and enlightening. Since we do have a few minutes, I do have a couple questions on my side. They're not super critical, but things we have a few minutes. First one is, I think, an easy one. What's the status of the CoServe specification in terms of its progress through the working group kind of maturation steps, eventually, becoming a standard? Where do we stand there?
Yeah, so we have an adopted draft. So it was adopted by the working group sort of in the autumn of last year. The recent draft that was published is version 6, which adds the support for queries by RIM identifier. I think with that, and maybe with the stuff that Giri's talking about for the queries by domain, that to me feels like it's bringing the thing to a kind of feature complete sort of status, and therefore we can start thinking about moving it towards a working group last call kind of state. We have actually requested a review from the HTTP Directorate because there is an HTTP binding described in this draft, so we'd like to get their feedback as well. So we're starting to get into a situation where we're reaching feature completeness, and as I said before, being quite militant, I guess, about trying to avoid feature creep, right? And trying to try not to allow the draft to become too big, too sprawling. It is at the moment relatively small because it borrows so heavily from CoRIM, right? CoRIM does a bunch of heavy lifting. On that point, though, of course, it does mean because there is that hard dependency on CoRIM's data model, it would not be possible for CoServe to become an RFC until CoRIM does. But I would expect it to not, I would expect it to queue up pretty eagerly behind CoRIM. Once CoRIM goes, I would sort of expect Hopefully not too many barriers to co-serve. I am, of course, being very optimistic and bullish in how I say that, and it's from a position of relative naivety because this is the first IETF draft to which I have contributed. So I can't speak from a lot of prior experience in terms of what wrinkles there might be in the road. But what I can say is we're trying to keep the thing as damn small as we possibly can, to have it just do what is necessary beyond what CORIM already does, and for it to be very small, very tight, very limited, to try to avoid, a kind of working group analysis paralysis sort of situation.
Mm-hmm. Mm-hmm.
But I don't have I don't have a timeline, right?
No,
I can't say, yeah.
yeah, that's
You
perfect.
know how it is.
That gives me exactly the information I was looking for, which is, so perfect. Thank you. One other question, and that we've lost Thomas, so we may have lost perhaps somebody who would comment to this question also. You mentioned in the Rust implementation for that demo that was using CoEVER, I think it was,
Cover, yes, yeah, or cover, yeah.
so I think you described that as a Rust implementation of, I'm going to use the wrong words, but of the CORAM reference verification heuristic or algorithm.
Yes.
And so, and you said that's part of the Verizon repos there. There's also,
Yep.
in my understanding, a Gover implementation. So I guess that's intentional, or how do these two? Are these like both kind of active and supported and equivalent, or is one richer than the other? And
Um, I'm not aware of one in Go. Is there one in Go as well? If there
well,
is, that's
maybe I'm misinterpreting. I had AI do a scan of the Verizon code base in the last week, and it told me there was a Golang implementation. I haven't double checked my AI analysis, but how's that?
I see. Yeah, I think that AI might have uh,
But
might.
Verizon itself can do implements verification, right, and
Oh,
produces new
absolutely.
results, right?
Absolutely.
Right. And
Yes,
so and
yes, of
it's
course.
and
Yeah.
is it funking down to Rust for the cover, or is it you have a
No,
Golang?
no, no, no. So Cover is the reason we use Cover is because Cover presented itself naturally as a good example of a tool that could do a verification outside of the context of the Verizon service, right? Because we wanted to exemplify this situation I had right at the start of, oh, damn these unwanted animations. This picture I had right at the start, right, where we wanted to kind of exemplify this idea of a verifier that just lives outside of the service and needs distribution. Cover just kind of emerged naturally as the thing to base that on, because Cover is standalone. It is, it doesn't require the rest of the Verizon service infrastructure. You just feed it evidence, and you feed it endorsements and reference values and as triples. And it can, it can do the validation algorithm for you. So it was the most obvious thing to use to exemplify this idea of sort of offline verification, if you like.
Hmm. Okay, great. Thank you, Paul. Any other questions? Okay, looks like we get 7 minutes reclaimed in our day today. And thank you everybody for participating today. And at the moment, next couple weeks out, Pushkar will be coming back to continue the conversation about data integrity for disks and confidential compute environments. So thanks everybody. Have a good couple weeks.
Okay, thanks for listening. Okay, take care all.